Okay, this is the second video on trigonometric integrals, and we're going to look at two examples of kind of sort of outliers. Don't see them as much as some of the other trigonometric integrals in terms of the homework or what's going to be on the test, but certainly good ones to take a look at. So we're going to look at a definite integral here, and this is the integral from 0 to pi of sine 3x times cosine 5x dx. And so we're going to have to go get a formula from pre-calculus. I think we call it a product to sum. So this one specifically, the sine of A times the cosine of B is equal to 1/2 sine A plus B plus sine A minus B. Okay. And there's a couple other ones there listed in the notes, which ones you might need. And we get these from the angle, sum, and difference formulas from pre-cal or trigonometry. Okay, so we're going to go ahead and apply the sine of A cosine B equals 1/2 sine A plus B plus sine A minus B, A being 3x, B being 5x. Okay, so this is going to be 1/2 integral from 0 to pi. Okay, sine of 3x plus 5x is 8x. Plus the sine of 3x minus 5x would be negative 2x dx, and we'll go ahead and integrate that. So it's going to be 1/2 negative cosine of 8x over 8 minus the cosine of negative 2x over negative 2, evaluated from 0 to pi. So it's going to be 1/2 negative cosine of 8 pi over 8 plus now cosine of negative 2 pi over 2 minus negative cosine of 0 over 8 plus cosine of 0 over 2. So it's going to be 1/2 of negative 1/8 plus 1/2 minus negative 1/8 plus 1/2. And so we are subtracting the same number from itself, and so that's going to end up being 0. So this integral ends up being 0. Okay, we're going to look at one more example here, and we're going to look at finding the integral of the secant cubed x dx. And so for powers 3 and larger and being odd, so 3, 5, 7, etc., the integrals of secant cubed, secant to the 5th, secant to the 7th, etc., are going to have kind of a similar process here. And so for dealing with secants and tangents, the derivative of secant is secant tangent, and the derivative of tangent is secant squared. And then, to rewrite secants in terms of tangents and vice versa, we're going to be looking at the Pythagorean identities, which means we need a sine squared, a secant squared, or a tangent squared. And so we could try something with a secant squared, and we would convert that into a tangent squared plus 1, but then the derivative of tangent squared would be derivative tangent would be secant squared, and we'd only have a secant, so the u substitution wouldn't work out. And so one of the new strategies we do have is integration by parts. So we can actually use integration by parts. So for our reference, the integral of secant squared is tangent plus c. So we're going to rewrite this as secant x times the secant squared x dx. And we're going to do integration by parts. So we're going to say u is equal to the secant of x, and differential dv is going to be secant squared x dx. Differential du is going to be secant x tangent x dx. V is going to be the tangent of x. So then this becomes the integral of u dv, which is uv, minus the integral of v du. So this is going to be secant x tangent x minus the integral of secant x tangent squared x dx. Now if we take cosine squared x plus sine squared x is equal to 1, and we divide everything by cosine squared divided by cosine squared is 1. Sine squared divided by cosine squared is tangent squared. And 1 divided by cosine squared is secant squared. Okay, if we solve this for tangent squared, tangent squared is equal to secant squared x minus 1. So we're going to make that replacement. So this becomes the secant x tangent x minus secant x times secant squared x minus 1 dx. Now the secant cubed x, the integral of the secant cubed x, is equal to secant x tangent x minus the integral of secant cubed x dx. Okay, so this is kind of like that integral that we looked at back in the integration by parts, where you end up getting the same integral as you're going through the integration by parts. So that's going to be good. This is going to work out pretty nicely here. Okay, and then plus the integral of secant x dx. Okay, so we're going to go ahead and move the integrals of secant cubed over to the left-hand side. So we're going to add the integral of secant cubed x dx to both sides. And then recall from Cal 1, the integral of secant was the natural log of the absolute value of the secant plus the tangent of x plus c. So 2 secant cubed x dx is equal to secant x tangent x plus the natural log of the absolute value of the secant x plus the tangent of x, and then plus c. Okay, and then the last thing we need to do is just to divide both sides by 2. So the integral of secant cubed x dx is 1/2 secant x tangent x plus the natural log of the absolute value of the secant x plus the tangent of x, and then plus c. Okay, and so there we go. The fifth power will work similarly. We'll end up getting a secant cubed in there, and so we'll use the fact that we have the integral of secant cubed here. You'll get a secant to the fifth, and you'll add that over to the other side like we did here with the secant cube. Okay, since we've made it a practice in these last videos here to go ahead and verify, so let's go ahead and verify. So I want to take the derivative of the 1/2 secant x tangent x plus the natural log of the absolute value of the secant x plus the tangent of x. Okay, and then plus c. No, we didn't put the plus c in there. It doesn't really matter, but we'll go ahead and put it in there because the derivative of that's going to be 0. Okay. All right, so we got 1/2, and then derivative of secant is secant tangent times the second function of tangent plus the first function of secant times the derivative of tangent, which is secant squared, plus derivative of natural log of the absolute value of a u will be u prime over u, so u prime is going to be secant x tangent x plus secant squared. Okay, so there's your u prime, and the u is just secant x plus tangent x. All right, so you got 1/2 secant x tangent squared x plus secant cubed x plus factor a secant out, and then we have tangent x plus secant x all over secant x plus tangent x. So those are the same factors. So those are going to absorb out. So you got 1/2, and we're going to factor out a secant, and then out of the first term and the third term. So when we factor the secant out, we're going to have tangent squared x plus 1, and then plus secant cubed x. So this is going to be 1/2 secant x, and tangent squared x plus 1 is secant squared x plus a secant cubed x. Okay, so then we're going to have 1/2 of secant cubed plus secant cubed. And so that's going to be secant cubed, which was our original integrand. Okay. Alrighty, so that concludes this video. So for more videos, or for examples on integrals involving secants and tangents, that's going to be in the next video. So we'll see you next time.